Recording?
Yeah. Okay, so hello everybody. I will stand, people in the room. So I'm really glad to be here. I'm also really honored that you know who I am. That some of you know who I am. Just for reference, I live in Malmo, Sweden, so it's just 1 hour away from here by bike. If anybody feels funky, you can join me later after dinner on a joyride all the way back to Malmo. There's also a train for those less adventurous. Let me see if my slides do work. Yeah, there you go. Since you mentioned the European Open Source Awards, I had to put the slide here. Just to make a bit of marketing. So I'm one of the founding members of the European Open Source Academy. This is a new effort that's born from a European project, but it has the goal of establishing as a self-standing foundation that should be awarding on a yearly basis those who are involved in the work with open source and should be giving away 4 or more awards every year. So I'm now in the process of nominating people. So if you know anybody who you think should be nominated from this community, I would be really glad to collect names and bring them up to the rest of the academy and have a conversation on how that's going to go. For now, the nominations are being evaluated by people that are core to this European project, plus the 4 awardees from last year, while we grow the academy. Hopefully, in 3 years, we will be 12 people in the academy, and we should be the ones evaluating the awardees coming in the future. We have an open nomination process and so on. We're putting everything in motion as we speak. So we're having very interesting discussions such as, oh, where shall we register the foundation? What about Luxembourg? That sounds great. You know, those kind of things that are really, really practical and extremely boring at the same time. One of our first projects is going to be to participate and run one of the hackathons at the United Nations Open Source Week. That's going to be in June this year. So who knows, maybe we might meet there at some point. If you happen to be there, please reach out and remind me who you are, because I'm terrible with names and faces. I need to think about 20 times before I remember who you are. I'm lucky I remember who my wife and my daughter are. You know. When I come home, they tell me, yes, you are at the right place. So that's the level. Anyway, putting this aside, so I'm David Cuartielles. I'm one of the founders of Arduino. I'm also a full-time teacher, head of lab and so on at Malmo University since 25 years ago. So I moved to Sweden for good, looks like. And so all of my pension money is here, so I don't think I can move anywhere at this point. You know, I'm 15 years away from retirement, they say. Well, once they change the law, it's 19 years away from retirement. Oh, it's the picture. Go. I will tell you when I really need a picture from my slides. So I will tell you, because we are talking Linux here, I'm gonna just give you like a brief glance on Arduino's Linux efforts. Okay, besides the IDE, which you already know about, and when I was discussing with Ramon about what to talk about here, I said, well, Arduino Portenta X8 sounds like the thing to talk about. It's like our safe hardware that's supposed to be used in the industry. But then I realized there are other things that really matter to me, and I think they can influence the discussion about security. And hopefully the ideas I will throw at you today will help having yet another variable to include in your discussions. So I will include the sustainability issue, obviously, just because. So Arduino is well known for their low entry educational boards. This is our latest power horse, which is the Arduino R4 with and without Wi-Fi. And this is a thing that's done in the very open source hardware way and shared with everybody, and people use it for learning and building their own robots and whatnot. Our previous model, the Arduino Uno R3, has been copied tens of millions of times. It's the most copied open source design that exists, to my knowledge, after the fork, maybe, you know. And but this is what we believe is going to be with us for some years to come. And it's a very basic microcontroller board that can be used for different things. We also have documentation, and I was instrumental in creating the whole documentation site for Arduino. Actually, both creating the first documentation 20 years ago and also doing this big effort in translating the documentation in a way that can be used in contemporary terms, not just by people, but also by contributors. Right now, the Arduino documentation is contained in a single GitHub repository in a completely open fashion. Anybody can go there, can clone the whole repository and print a book with it and sell it and welcome. Then please give us some money, but be nice. If you want to contribute, we use GitHub as a, let's say, identification mechanism, but we ended up having too much kind of contributions that were of dubious origins in our website. So we use GitHub as a way to filter. Then we have the software, which is based on a whole framework from the Eclipse Foundation, to which we contributed with multilingual support. So if you need to make a multilingual IDE of any kind, I invite you to take the Arduino's framework as a point of departure, because it already supports having 20, 30, 50, 100 languages in whatever way you want. Okay. And again, it's under GNU, sorry. And then we have a very rich ecosystem of libraries, and we're talking thousands of libraries with a tremendous variety of licensing models. It's almost ridiculous. You know, it's like, well, I want to make a project. Okay, this one is BSD, this one is MIT, this one is whatever. And it's like, in the end, what's my project? I don't know anymore. You know, it's like, but this allows you to choose. You know, it's like you can choose in which way and how much you want to share with the world. That's really up to you. We made our core so that you don't need to share our core, which is already publicly available if you don't want to, by adding a lot of our parts to be GPL. So if you want to make your core hidden from your customer for whatever reason that we don't understand, that's really up to you. You know, it's like we want maximum freedom there, and that's it. But then talking about Linux, and I have to excuse myself with the European Commission about the tilted logotype, but it didn't fit with the board. And also for the extremely pixelated board, this is an old board. This is Arduino's first Linux board. So besides having our IDE made in Linux, and with the viewers later on, I can tell you about how we managed to get Linux to run in all flavors. Also, Arduino running all flavors of Linux through a stay that I had at the Hackerspace in Barcelona, where everybody had, you know, if there were 20 people, there were 24 versions of Linux. I don't know how they did it, but the first embedded Linux we had was this one. It was an embedded, it was an OpenWRT. So we basically took kind of like a chip that was used for like an access point and put it on a board and added a microcontroller to it. And this became our paradigm of use. So we believe that you need to have a system that runs an operating system at the higher level, and then you need to have a microcontroller for the low-end parts. And that's our approach to it. And this was made through a European project that was called the Social Housekeeping Through Intercommunicating Appliances. And okay, too much. Acronym, social and smart. And this was about, okay, listen to this. This is about making connected kitchens. Okay? So the idea is like, I want to make a connected kitchen. Let's say that all of the appliances in my home connect to the Wi-Fi. We did this over 10 years ago. And we were like, okay, how are we supposed to do that? Or we need to make a board that can connect to the Wi-Fi, that allows you to have low-level control of stuff. This gave birth to this board. And with that, we could make a lot of tests. But from there to this, there is a lot of time. This is our strongest computer, and I will show you the features of it. This is called the Portenta X8, and again, it was funded by a research project from the European Commission. The first thing you see when you look at it is that it has no pins. It's like your first point is like, hey, well, can I make my light blink? Don't worry, you have 160 pins on the backside, high density. So you can connect 160 LEDs if you feel very funky today. But the idea is that you can connect, it obviously has connectors for camera, screens, you know, all the standard protocols, has like a Ethernet 5 or whatever, you know, everything is there. For some reason, yeah. So this comes from another European project. It's called the Decode project. And the goal of this project was to create a system that could sign your sensor information with blockchain. So you could make sure that your data was the one that was sent to the server, whatever. So people could refer to you as the provider of certain information. And for doing that, we need a Linux computer. And that gave birth to this board. So I spent, I don't know how many hours, but I used Phoronix to evaluate multiple single single chip boards, and I came to the conclusion that none of the existing things in the market was good enough. So we talked to NXP. NXP offered us a processor IMX8, and we made this board that is now about 8 years old, give or take. And this board is our industrial computer. So in a nutshell, this thing is, well, it runs in extremely low and extremely high temperatures. So you need to have a system that runs at -20 degrees. This does it. It runs with Linux preloaded. It has Yocto Linux out of the box. It works with a modular container architecture. So you develop in your computer and then you put it in a Docker container and you send it to this board and it just runs it. And it has also real-time through the Arduino IDE. It has a second microcontroller on board that can do any kind of low-level things. And well, has connectivity, a lot of connectivity, and you can do upgrades over the air, which is pretty crazy. And we have fleet control, which means that you can basically have 100 of this, and you say, oh, this beautiful Docker that we just made, and send it to these 100 boards that I have here, and it does it over the air, and you have to care about it. Isn't that beautiful? That's that's lovely. Well, believe it or not, people don't really buy this board. It's 200 euros, so that's why I didn't bring any to give it to you guys. I'm really sorry, but this workshop will be like the end of the whole company. Anyway, one of the key features, and I think what is very important for security for us, is that it has hardware identification. So we have an NXP encryption chip that allow us to identify each word uniquely, and we have certificates to go against clouds and whatnot. Okay, that's key in hardware design, and most systems lack that, or they simulated by a software, and then it's not secure enough. Okay, so this is the idea. Really, you have the possibility of hardware identifiers. If you want the features, I will share the slides with you, but I think this is key. We have two processors, one Cortex A53 that runs at 1.8 gigahertz with 4 cores. And inside that chip, there is also another Cortex M4 that runs at 400 megahertz. So it has a microcontroller and a microprocessor. And then on top of that, we have another microcontroller that has a Cortex M7 with M4 to do like the low-level integration. Okay, when you want to do something like make my light blink very fast, you use the microcontroller. You could do it with the other one as well, but you know, why? If you have a cool microcontroller to do that job. Typically, when we serve this board, we serve it headless. You have, even though it has a USB-C and you could actually have video drivers on it, you don't use that way. And when I made the first demonstration, I was running Debian on this board for the European Commission when we finished the project, and I basically went in command line and I issued some commands to prove that we actually used the money they gave us to make this computer. And it was quite impressive to everybody, me included, because I wasn't really engaged in that part of the process. So, you know, it was quite cool to say ls or delete the directory from, you know, command line and then Arduino board. That was quite amazing. A great feeling. Just to give you a bit of an idea of the technical specs, here you can see them. So it has 2 gigabytes of DRAM and some other stuff. The secure element is here on the B side, very hidden, and so on. If we look at like low-level hacking security aspects, the secure element should be included inside the microprocessor, but who does that? There's definitely the NXP doesn't sell that together integrated in a single piece. You have to have the external piece, and that's probably the biggest flaw in security in this whole thing. And somebody could dare and listen to the line that sends the signature and so on. Even though it's encrypted, but you know, it's always problematic anyway. So you're on Linux. Yes, we run Linux, of course. We run Yocto, and it's very slow. You develop in Docker, as I said, and you do OTA through Foundries, and you can do fleet management. And you link to the microcontroller through our PC, so you can actually have one thing doing its processes and use a queue system to send commands back and forth and make sure everything works in real time. Even though this thing is so fast, you can actually, do you really need a microcontroller? That's a question I ask myself, right? But yeah, you can use it. It's cool. So, okay, this is what Arduino is famous for, which is user experience. So here you go. So in which way can you use this? Well, you can access the board. The board by itself offers you a web interface that links you to the whole experience. One of them is the web IDE, and it links you to the Arduino cloud, and then you can start developing Arduino code for this board. But it also links you to the Foundry system. If you have a container, you can upload the container and can be deployed and so on and so forth. You can also work in command line. And oh yeah, sorry. And then you can have, we have a WebGL connections, and you can actually show things on the screen from the board. So you can make kind of like a kiosk mode as well. But it's not the main interaction. So it's not like you don't boot to it with a keyboard and a mouse and start programming directly from it. You have to work over SSH or it doesn't work. That's a let's say secure by design approach that we have had to this. So then we have plenty of examples, like you can run Node-RED on it. You can, as I said, have OpenWebGL content shown on the screen. You can install WordPress on it if you feel extremely funky and you love automatic still. You can do this. Sorry for this joke, people at automatic. And then you can do other things. And one of the interesting things of this board is that we consider it to be our basic computing device, and then you have different boards to do different things. For example, you can build a NUC-like computer where you plug the board in, and it has more connectivity even if you can. This one has LoRa and Narrowband IoT, plus all of the other things you see there. So you can make industrial computers and run them on a battery. But there is a collection of different artifacts you can connect to it. You can add a camera and do computer vision projects and whatnot. And let me ask this question: how many of you knew about this board? My friend and my friend. Okay, people typically don't know about Arduino doing this kind of things, and it's normal. I mean, you know the cry you were making earlier about that that people don't take you seriously. Well, people don't take us seriously either. So we're together in this. I guess it's the open source cry for help. Anyway, but that much for a sales pitch, because this was the title of the slides. And now I'm going to talk to you about the things that really excite me, which is making biocompatible electronic boards and how this can affect the Linux ecosystem in the future. And I would like you to invite differently about different ways of considering electronics. So I'm working in this European research project currently, and the acronym is really fantastic, you know, Desire. Yeah. But the idea is to create a whole circular approach to electronic design for Europe. And obviously, the big question is how to reconcile the SDGs with electronics, right? Specifically, we're looking at responsible consumption and industry innovation and infrastructure, right? So how can we reconcile these things? So there's multiple ways. Many people have been working with this. For example, ST has been proposing this roadmap on how to deal with the e-waste produced by electronics. We at Arduino and we in this project have decided to focus on the design aspects and the manufacturing. So in this project, we are tackling those two problems. So which are the design guidelines that are needed to manufacture boards that are somehow biocompatible? And our approach is to change the substrate of boards to use a bio-based material. In this case, we will use PLA flax. PLA flax, well, everybody knows PLA, right? PLA from 3D printers. Yes, man. So what happens with PLA? It melts at 200 degrees. How do we solder boards? At 400 degrees. Yes, I guess you get the challenge. So yes, my friend. So this is a real problem, right? Like traditional electronic boards, they are made, well, let me just put a better picture. This is better for now. Traditional electronics, they are made with FR4. FR4 is a composite made of like glass fiber with epoxy. And that becomes an extremely durable material, super, super strong, weather resistant, you know, will survive an earthquake. You could just build houses out of it if it wasn't because it would probably give you like a million allergies, okay? But as long as it's in electronics, we are all good. The problem is that those boards, they take forever to recycle. They take hundreds of years to recycle. So what if we change that substrate for PLA flax? What if we change the substrate for a material that can be somehow decomposed either industrially or by nature? Industrially, right now we can decompose a board in 2 days. in an industrial process, heating up the board and adding some magic chemicals to it. So the problem is that industrial processes are very complicated. If you think that certifying software is crazy, just imagine making a PCB, okay? Just at the PCB factory, I'm gonna give you a glimpse to a PCB factory. You have 70 processes just to make a circuit board. I'm not talking about populating it, I'm just talking about the board, but with the copper and so on. This is actually a real image from the factory where they make the Arduino boards, okay? This is I have the permission to show you this from Alba PCB, one of our partners. And they gave us this when we came to the factory. They said, well, you're going to enter this 2,000 square meters facility. We do these 70 processes. And you start looking at it, it's like choose your own adventure going wild. And so this is, for example, you have to CNC the board. So you have the board, you glue the copper on top, and you have to make the holes as a first step in manufacturing, right? Well, when you drill, things get hot. When things get hot, they melt the PLA again. So you cannot drill the same way, okay? Then you have to put things through acid. This is a huge, huge acid line. So these yellow things, these are robots, and they can carry like 4 times 3, kind of like big electronic panels, and they dip them in acid. You know, it's like when you're washing something in water. Well, you don't do this anymore. You have washing machine, right? Imagine that you were like your grandmother, you were like washing the clothes in the river. This is how you make PCBs. You put them in and you put them out. And by making this movement, the acid removes the copper that's not supposed to be there from the boards. So yeah, that acid is extremely aggressive. And it will probably not work the same way on biodegradable or biocompatible, substrates. And then you have really long washing lines. That shadow line, that's a super long washing line. There's thousands of liters of water needed to wash every board. You wash it multiple times to remove the remainder of the acid and then to remove the protection layer that you put for the lines that are not going to be taken away by the acid and so on and so forth. And this water is not always cold, it's also hot. And then one of the funkiest parts is that box you see with high Andras. That box is used to cook the paint. When you put paint on a board, you do it to protect the lines that are not going to be used. Everybody talks about the silk and so on, right? You can paint it green or whatever, and then you have the layers on top and so on. Well, that's an oven that heats up at 100 degrees, and the boards need to be there for over an hour, so the paint dries up. Well, if you put PLA at 100 degrees for an hour, you compromise the mechanical properties of PLA. So let's say that 90% of the processes to make a board are not good for biocompatible, okay? Don't worry, I will come to the point why this is important for Linux, okay? You will not believe this. And then of course there is testing, and testing is not aggressive at all. It's like a robot with like a lot of needles and goes around measuring whether the connections work properly as they are expected to work. So we have the PLA flags at this point. We only 1 year in the project, and we already have this working substrate. When you cut it and you use it to biases, you see it's very similar to the other boards with FR4. And we are able of doing all of the processes in the lab, not in the factory. Okay, so we can make 4 boards at a time, not 4,000. Arduino makes 5,000 boards a day, just to give you a hint on how many boards we need to produce. So it's so now then you go onto the mounting. This is the factory where we mount the boards. It's a company called Omaric. It's in the Piedmont, in Italy. It's a funny factory. The guy makes circuit boards and he restores all the ambulances because you can do many things in life. This is Marta, who works for us, and she's explaining how to do traceability. In this particular machine, that's a laser machine that's giving a QR code, individual QR code to every single board. So when you get an Arduino board, there is somewhere on it a QR code that allows us to know which word you have and whether if something's wrong and we identify too many wrongs on the same batch, we can call all of the boards back and make sure people get their boards back. This is just to tell you why you should buy Arduino and not clones. Because we can replace your bad boards, because we know you have a bad board, if you have one. There's pick and place, and there is soldering. This is a reflow oven. Currently, this one has different zones. So the board comes in from one side and it's slowly heated up. So if you make boards in your lab, you typically have a single oven and it follows a curve, heats up and then cools down. The way you do that in an industry is that you have several ovens that connect with one another and they go at different temperatures, each one of them, and then you move the board. So you don't change the curve, you move the board. So this one goes up to 260 degrees. The board has melted 5 times at that point in this process. Okay, so reflow is very different for us. And then you have the testing, and this is Arduino's secret jewel, which is the testing process. What you see on the sides are different testing machines. We have every single board is tested one by one, and it's reported back to our system. Because it's funny, the whole system is called ramen because it's a bunch of spaghetti with like different machines that connect to one another, and they connect to the central and report the data and so on and so forth. That also runs Linux. Cannot tell you exactly which one because I will have to eliminate you afterwards. But yeah. Well, with all of this, here's where we are today. Today, we have Arduino boards made in the lab, made with bio-based board components. So we do have Arduino Nano and we do have Arduino Uno already working, fully functional, but not made in a factory. So make the factory is the next frontier for us. So 2-layer boards are no problem, but what we have discovered is that we have to do certain things. For example, biases, they have to make double, as you say there. See, so the design has special design guidelines to be biodegradable or biocompatible. Sorry, biodegradable is not the right word. I keep on saying that bad. So if you are into electronic design, these are your rules. If you follow these rules, you can follow the same process we are following, and you can make biocompatible boards. So there's still research to be done, obviously. For example, while these boards are not biodegradable, which means they will not be destroyed by nature, we still have to do the composting test. You know, this is a special test, it's a standard on how to test boards. And what you see here is the lab. We're burying the boards inside compost and see how long they last. And this is our first worm eating a board. Okay. Unfortunately, this process, I mean, that worm is now contaminated with microplastics, but that's a different story. Unfortunately, this process does not end up in proper nutrients for the compost. That's why we don't call this biodegradable, okay? Because this degrades the board mechanically, but doesn't really degrade them to make them something else. So we need a chemical process, industrial chemical process, to really degrade them the way we want. So at this point, we can do that in the lab in 2 days. You know, we have these bases, we put the boards and we do bio-leaching and so on. So it's not the goal of this project to make biodegradable boards, and nobody has those in the world. Whoever says they have it, they lie. Not even Infineon with like the power amps that they say they can be dissolved in water. They still have this problem. Okay. So biocompatible is not the same thing as biodegradable. This is what I'm trying to say. But nevertheless, this has to be tried out, and we believe this is going to work. And there is science supporting this. There is some challenges. For example, dielectric is not the same, so antennas don't behave the same way. You know, it's not the same thing to have this kind of thing. We're making a board that's going to be having a TinyML compatible processor, and it's going to have LoRa and radio communication. So we're actually making an antenna on board to test all of these things all at once. And we're going to make 1,000 of these boards and give them away. So if you want to be in the beta testing process, call me in 2026 and we can make sure you get a board. Okay. But the science is all there. So it's possible to also solder at something like 120 degrees. There is composites that allow you making this soldering, the cold soldering, and so on. So I'm coming to basically formulate 2 principles for secure and sustainable electronics. And this is why I'm going to link back to Linux. And first of all, it's called manufacturing, refers to the lowering of the production temperature. So we need to take all of the machines and do like, and what happens when we change the temperature to be a lower temperature? How do we have to change the chemistry of the whole production chain? That's the big question. That's what this project is all about. Good. But then we come to the other question, which is what I like to call just enough technology. So which is the computing power enough so we can still have a chip that can have the right pitch so it can be placed in a biocompatible board. Because the problem is that we cannot solder VGA, man. This is a real problem. So all of these beautiful chips you guys use to run Linux don't run here. So how can we make a Linux computer that has like 48 pins That's the big question for me, right? So, and that's why we're talking about this vision of just enough technology. And we try to look back at the time of, for example, working with logic gates, and you have the NAND gate, and all manufacturers were making NAND gates. Right now, all manufacturers make different Linux processors. And in my opinion, we need to have a convergence of these processors so we can substitute them freely between producers. That's why I told you I was going to talk about really wild and crazy ideas. So I hope you will not think I'm too crazy when I'm saying all these things. But I'm going to apply for an ERC project to just do this. Okay, this is my personal goal. So my question for you is, can we consider standard pinouts to be used by different vendors? What will be the minimum amount of pins that you will need to have a safe Linux computer? Which are the minimum peripherals you will need to have to make sure everybody can use them? So to answer this question, I think we need to think from the use perspective and not just from the power perspective, right? You're talking about certification, you're talking about different things, you know. For example, my users, they need to make sure their systems are certified, so otherwise they cannot buy it. I have a lot of institutional users, and it's a requirement for them to have it, right? If they could have certified materials from different people, that would be great. The same thing, that would be great. Anyway, with this, I'm basically finished my presentation. So
something about PCBs.
Yeah.
I'm curious about your PCBs. To have a safe system, you need to have certain quality on your software, but also certain quality on your hardware.
Yeah.
Typically, hardware is covered by different standards, but let's say that normally involves a high temperature over lifetime test.
Yeah.
Meaning that if you bake it on a modem for a long time, a lot of time to emulate cycling and
Yeah.
aging. I wonder how this will work in that. I mean, does that fit or is it?
Yeah, this is the thing. The problem is that right now we're applying the same standards to all use cases or to most use cases. You know, but for example, if you have a computer to be used in a classroom, then you need to like cook it in oven at 150 degrees for 3 hours.
Yeah, okay.
You know, that is the question. So if from a sustainability perspective, we have this one size fits all approach, then we are sacrificing the possibility of making systems that are a lot more sustainable. That's the idea. That's just for the substrate. From the computing perspective, you can use the same processor in both cases. And also,
have a special bits, special pinout.
yeah, but also if the processors have similar pinouts and let's say older pinouts, they're easier to desolder and reuse. It's still possible to reuse VGA. You have to be able to practice, man, but you still, you know, but we saw like taking like a normal 48 pin chip or even a 64 pin chip, desolder and resolder, that's perfectly doable by hand. You know, so what we're looking at is the possibility of reusing the parts. I didn't enter into that part in the circular economy aspects of the project. I'm only looking at the substrate, but yeah. But the question is, do we need to evaluate everything the same way? This is really the big question we are asking. Because not everything is going to be in a car. You know, we understand you need maximum safety.
Absolutely. Yeah, I'm not saying that.
Yeah. No, but that's definitely a very valid point. Like, which are the cases when you need this very durable PCB that is so hard to recycle versus?
Yeah, but this test is not there. This is a validation test to ensure that this test can have emission profile of an years. I don't know how you calculate the emission profile, but the high temperature over lifetime, for example, tests are done in that way in order to ensure that your product will be able to withstand the aging. So your electronics, your board, your substrate, everything will be. Do you have what I'm trying to say practically is not that it doesn't work, it's have you found a replacement for this process that will.
Yeah, well, like, we're looking at consumer electronics, which typically don't have a 10-year lifespan. For example, okay, we can talk about this for hours, okay, but the only e-waste facility in Europe that recycles motherboards is in Belgium and recycles mobile phones, but they don't recycle computer motherboards, for example, or laptop motherboards, because the mobile phone motherboards, they have precious metals that can be recycled and is economically viable, while the other ones are not economically viable. but we have a substrate that allows to really separate everything faster or better, then it will be much easier to recycle the components. So that's really like our approach is to facilitate that. What this could lead into is actually a new obsolescence kind of vision where boards will not last 10 years, they will last 5 years. So, but again, if we really can reuse the components, because for example, Arduino components are designed to last 40 years. Like the ones that have been tested in chambers. We haven't tested them, but we include components that have been tested. Theoretically, they can last up to 40 years. So, but will those boards be working for 40 years? I highly doubt it. In most of the cases, they won't. So we need to also feed the rest of the ecosystem with systems that will be aging at the right speed. Anyway, this is a really valid question, and this is part of the debate. Actually, it's part of the debate. So yeah, we should give some credit to everybody involved in the project currently, and that's a wrap. Thank you so much.
The one question, the simple and easy one, which came from the virtual audience, was that you mentioned MIPI on the specification, and it was a question if it's MIPI CSI.
I cannot answer that.
I'm pretty sure Yamaguchi-san it is.
They can take a look at it.
Yeah, I mean from how it looks like, it's like MIPI CSI interface. Yeah. Okay, great. We're totally over time. And it's good. It was a very entertaining and nice presentation. Thank you so much for it.